Nitish Kulkarni. Hope you're doing well and welcome to my channel Cosmic Science. So, in day to day life, we need some kind of energy, in the sense, capacity to perform some activity, uh, kind of urge or, or a power to perform some kind of activities like walking, like I'm talking to you. It requires some capacity, right? So from where it comes from, whatever the food we have, whatever the nutrients we take in, it comes from that. So in basically science defines the energy. uh, it goes like this. Energy, science defines it as, it is a it is a capacity to do a work of a body. What is this capacity to do work? What is this work? Work is nothing but a motion or a state where it performs some change, or it displaces when other forces apply to it. In simple way, a capacity or a ability to perform a activity, or when a force is applied to it. If I apply a force, this to this um, what do you say, marker, and if I throw it at the camera, so I'm giving it a force and it is displacing to a camera. So this is called this. I'm giving it energy, and it is doing some work when it by moving from here to there, displacing, and I'm giving it a force. So this is a work. So capacity uh, to do to do this work is called energy. So there are different types of energies, like electrical energy, light energy, mechanical energy, and many other different types of energies that exist. For in considering mechanical energy, here mechanical energy, mechanical energy, mechanical energy, it is the physical form of energy. It is produced. This energy is produced when there is a motion or a position of a body. Depends on the uh, physical activity. It depends. There are two types of mechanical energy. One, kinetic energy. Second, potential energy. There are two types of energy, mechanical energies: kinetic energy, potential energy. Let's see first what is kinetic energy. So, what is the basic definition of energy? Energy is capacity to do work. So, what kind of work? The question comes, right. What kind of work? Capacity to do work. The capacity is there, but what work? Here in this kinetic energy, what type of work it is? It states that it is in it is the virtue of the motion. Here, the energy is elaborating or expressing itself, its capacity by motion. In simple way, uh, kinetic energy is nothing but uh, of a body to capacity to do work by virtue of its motion. It does the work in the form of motion. Like I said, if I throw this uh, marker to camera, I'm giving energy to force to it and displacing to the camera. So I'm giving the force in the form of motion, which is converted into motion. My force is converted into motion. So this is kinetic energy. Energy capacity to do work is energy, and kinetic energy is work done by a body in the form of motion or by virtue of its motion. Energy of a body in the form of or in the virtue of its body. So this is kinetic energy. There is some theory or a theorem you can say uh, on kinetic energy. When force is constant, if I applying constant force when it hits the when if I in whole space, if I throw it and again gets slow, so I am giving the constant force to every at every point. So what will be the equation for it? Let's see. Work energy theorem. Work energy theorem of constant force. Of a constant force. Let's see. For rectilinear motion, what is rectilinear right now? Rectilinear in the sense in a straight line. For that, the equation is rectilinear motion is v is equal to v square is equal to v naught square plus 2ax. So this is the equation for the rectilinear motion, right? So what if I write it in a vector form? It will be v square v naught square plus 2a dot distance d. Why did I write x as a d here? X is a distance. So I'm giving it a particular direction. So it come uh, so the distance is in a particular direction. So it becomes a vector quantity. So that is the reason I wrote x as a d here. Here, see the equation. What can be done to get a kinetic energy equation? What is the kinetic energy equation? K is equal to half mv square. How can I make a um, this as a kinetic energy equation by multiplying half m. So here this is half mv square and this is half mv square. If I take this in the left hand side, I can write it as half mv square minus half. This becomes minus when it comes here, mv naught square is equal to half m a into d. So uh, what is half mv square? K, right? Kinetic energy minus k naught. Here it was 2 ma. This 2 and 2 gets cancelled. Ma in what is ma? What is ma? Force dot this distance. What is force into displacement? Work. So this is the final equation. What does it state? The change in the kinetic energy. The change in the kinetic energy of a particle is equal to the work done on the particle by force. What does this mean? Here, kinetic energy is changing, and it is equal to the work. If I'm throwing this uh, marker, if I'm uh, if I'm applying force and it is displacing, if I change the force, displacement will change, and if displacement changes, uh, its kinetic energy is going to change because its motion is going to change. If I at different points, if I change the force, if I change the work done, then the kinetic energy is going to change. This is the statement of work energy and theorem. Work energy and theorem. This is for all. Um, I'll come up with the next concepts again. So this was about kinetic energy and kinetic energy in brief. So we have seen kinetic energy theorem with a constant force. We have seen the derivation, how kinetic energy changes equally when work done on the object by force. This is for all. If you like this video, really, if you like this video, please comment down below uh, that which motive which motivates you, uh, what you felt good about the lecture, and or if you have any doubts regarding this, if you have any questions, comment down below. If you love it, if you are happy with the video, please do like, and if you want to others to see this video as well, and look, and also they want to get this information, please do share with them. um, so with this, I'll see you in the next video. Till then, stay safe, stay healthy, stay calm, stay motivated, think clear. Thank you.